Hello and welcome to first lecture in the 13th chapter of our comprehensive course on machine learning, artificial intelligence and data science. Now here we want to talk about this thing, data visualization. So where we are in the data science life cycle, then we are still in this region only. And as I said that we have been moving in this region for last 4 or 5 chapters, and we will still continue to move in this region for next 4 or 5 chapters, because this region is the heart for a data scientist. Okay, and rest of the parts, that is this part, of course this is also hard for the data scientist: business understanding and problem identification, and then dashboarding and report, that is also involves active involvement of data scientists. But this part, for example, data acquisition, or this part, for example, model monitoring and everything, and drift analysis. Now here often the responsibility is assigned to a different job role called data engineer or machine learning engineer. Okay, as I however said that our aim is to learn everything, because this course is designed to make one kind of data generalist and a full stack data scientist. So we will learn everything from here to here, but this portion is what we are discussing at present. So far we have done exploratory data analysis, and in previous chapter we had done something about data cleaning and some feature engineering, some very basic feature engineering. Then now we want to do about this data visualization. Now for the data visualization we have 4 chapters. This 13th, introduction to data visualization; 14th, that is advanced data visualization with matplotlib; 15th, introduction to Seaborn for data visualization, that is another plotting library; 16th, advanced Seaborn techniques; and 17th, that is combining plots and interactive visualization. For interactivity you can use another library called Plotly. So matplotlib, Seaborn and Plotly, they can handle practically everything with respect to data visualization. Okay, so let us start with the basic chapter at present. So principles of data visualization. Data visualization is fundamental aspect of data science which helps to translate complex results and data sets into a form which is easy to understand and interpret. Effective visualizations can reveal underlying patterns, relationships and trends which may not be apparent in the raw data. When I say raw data, that means for example that even the cleaned employee data, okay, we removed the none, we removed outliers, we did the deduplication, we removed any single valued columns if it is present. But still, by looking at this data, can you find some patterns? Because for example, here in the salary, now you move through your cursor through the columns, and what pattern you may see, that you may at least see some magnitudes of salary. But actually speaking, the pattern becomes clear when I visually express this data. And visually means what? That we have already done in previous chapter. So we know now that we can do univariate analysis, bivariate analysis, and we in univariate analysis mainly histogram, then box plot, then another is violin plot, etc. plotted. In bivariate analysis, pair plot, and then that scatter plot, then maybe line chart, then maybe relationship, correlation matrix or heat map. Many different things can be plotted, right? And when you plot them, then you suddenly realize that, oh, this data in which employee qualification is there, but I cannot know that for each qualification, say master, how many observations are there, or whether master qualification people are working more in my organization or high school qualification are working more in my organization. Also, if I plot these versus this, then I will realize that what is the correlation? I mean, how I am paying my employees depending upon their qualification. Is there some kind of disparity or anomaly that high qualified people who are not being paid well? So one needs to study the data for that. Then is there any relation between age and, for example, performance? So should I recruit more youngsters because there is performance, or maybe it is possible that higher age people are actually giving greater performance, the reason being their work experience. So all these things help me to take informed decisions about my data science, about my organization, future recruitment, how to improve the performance of my salary, performance of my employees, how to reduce my salary bill without sacrificing performance, and all that thing. Okay, which of my department are performing properly, which of my department are performing not poorly. All those things become clear. So such patterns cannot be inferred from this kind of tabular data, right? But when you show them by graph, and we had seen histogram and box plots and scatter plots and pair plots and relationship, correlation matrix and everything. So we now know that I know this data set much more in depth compared to what would I have known by just looking at this Excel sheet or CSV file, right? So data visualization helps to translate complex results and data sets into a form which is easy to understand. And effective visualization can reveal underlying patterns, relationships, and trends which may not be apparent in the raw data, right? So we will again take some examples, but you can see that after EDA or during EDA, whatever plots we obtain for univariate and bivariate analysis, they themselves are useful for data visualization, and they go here in the last stage of your data science life cycle when you are finally preparing the dashboard, report, and scores for your client end user. Okay, so end user will just provide data and there he is free, and finally after a stipulated 3 months or 6 months duration, whatever we have agreed upon with that client, he will demand that, okay, show me the dashboard and just give me final report and recommendation that how can I improve the efficiency and performance both of my employees. That's all. So he is not interested in all this, but visualization everybody understands, whether the person is technical or non-technical, anybody will understand visualization. Okay, now principles of effective visualization. Again, these principles are not to be learned like this and learned by heart, because we are not preparing for a university examination here. We are actually preparing as an applied data scientist who can actually work in industries, right? So these principles we will take by examples only, code examples and their corresponding plots. Okay, so clarity. First thing is clarity. Ensure that the visualization deliver a clear and accurate representation of data. For example, in one earlier chapter, when we plotted the pie charts for the same employee data, then I said that the pie chart for the employee date of birth or date of joining, they are not much useful, because the problem was I had some 50 employees and almost nearly everyone has a different date of birth. So there are too many segments in my pie chart. Okay, so then that type of pie chart is not much useful. But a pie chart showing the department and performance, that can be useful, because I have only HR, IT, sales, marketing, and maybe finance, these 5 departments. So my pie circle would be divided into 5 segments, and I can even express the aggregated performance of each department inside that pie, or how many employees work. That is what percentage of my employees work in each department. I can easily express by pie chart, right? So why we don't plot the pie chart for this? We plotted and then we deleted it because it was not giving much clarity of insight. Okay, so clarity is the most important thing. It should be clear and accurate representation of data. Accessibility. The design visualization should be such that they are easily interpretable by wider audience. So it is not that if you make a chart which only can be interpreted by technical people or engineers, then you are completely neglecting the business aspect of your craft. But ultimately you have to convince the stakeholders, right? And the stakeholders are mostly CEOs, the finance people. If you are running your own firm and you're looking for venture capital, then maybe venture capitalist and everybody. So you have to convince them, correct? So then they may not be technical people. So the visualization should be clear, easily interpretable by even non-technical people. And also one important thing about accessibility is they should be quick, such that it is easy or to grasp them quickly, because people at that level, CEO or VP of the company or the venture capitalist, they don't have much time for explanation. They should just need to look at a few diagrams, and immediately they should get the message. Okay, consistency. Now this is also important, that you should use consistent scales and colors. So sometimes your lines are thicker, sometimes thin, sometimes your January month sale you have shown by red color, and or say 2021 year sale is red color, and 2022 sales is blue color. Then that consistency should remain in other graphs also. Now in line chart you have used that color, and in bar chart 2021 cell is red color. So I mean reverse color, whatever was chosen for line chart. Then in that case it would create confusion. So consistency is important. Relevance. So relevance is also important. If you remember, when we handled this data frame for univariate and bivariate analysis, we had created several charts over here. Okay, and a whole separate folder was created, and our charts were saved in that separate folder. This employee details, bivariate, and all that. But there were so many charts initially, and then we deleted most of them, and we kept only those which are absolutely necessary, and which here also these are different charts, right? But we kept only those which are absolutely necessary, and there is no repetition. So then visualization should be relevant, okay, and limited number of absolutely needed graphs, plots should be taken. Each one of them should address some specific questions. Okay, then aesthetics is also important, because at one side there should be visual appeal. Okay, but on the other side functionality should not be compromised. Otherwise sometimes what happens is, and it is very easy to do that with with visualizations. I give you a very simple examples that suppose you are representing the income inequality, right? Now, actually speaking, your sample has a large income inequality, and some people have very low income, some people have extremely high income, and in every society that happens. But here, in your case, say maybe entire middle income group is extremely small. So for a healthy economy and healthy society, that middle income group should be reasonably large. Instead, most of the people are either extremely poor or most of the people are either extremely rich. Now, you can easily mislead your audience. Suppose you want to convey a message that no, there is no income inequality in our society and everything is fine with the economy. So you can just do one thing: your income graph, which is normally exponential, you can just take logarithm and show the graph in logarithmic manner. A small asterisk, you can put that the graph is on logarithmic scale and in very small letter, so that nobody bothers to read that small disclaimer, and people will get a wrong message. Okay, so that is a misleading graph. That would look also better compared to that exponential graph, because exponential graph is difficult to accommodate within one graph paper. But okay, it is having visual appeal. Okay, it will engage the audience, but it can mislead the audience, right? Okay, then what is the importance of visualization? Then one importance I told in exploratory data analysis we have already been doing. We are finding patterns, we are finding outliers, we are finding anomalies, right? Then other is reporting and storytelling. That is this thing: model monitoring, here dashboard, reports and scores, right? So dashboard creation is also a skill at which you will be better. Nowadays those tools are there: Power BI, Tableau, and maybe other dashboard creation tools. But still, there you have to just drag and drop the columns, but colors, etc., you have to choose. So you have to have some basic sense of aesthetics and color combinations which are appealing, color combinations which are engaging, color combinations which are repelling to the audience, like that. So that is storytelling. Storytelling is the final report which you have to present. And most of the data science projects are sold to the management or your client or your venture capitalist by effective storytelling. Okay, so sometimes it is possible that you have done excellent analysis and you have shown the benefits of using data-driven approach in your analysis perfectly, but the last presentation which you give to your client, that is not effective, and the impact will not be conveyed to the client, and he may not agree to loosen the purse strings. And without purse strings, what will happen? Even if your project is excellent, it will not see the day of the light. Okay, in fact, still today 75 to 70 to 75% of the data science projects are abandoned at the proof of concept stage. Okay, and one major reason is they are not effectively conveyed to the higher management by great storytelling and the model diagnosis. Now that is also important. What happens is, when you deploy your model at a very accurate model, you convince your organization, they have agreed to do the data driven approach, and now you have deployed your model on the cloud. But as soon as some new data comes, then it is possible that data drift may occur. Similarly, there is something called model drift also, and at that time this drift occurs. So you have to convince your management that there is nothing inherently wrong with your approach. Okay, such a drift does occur, and the remedy for that data drift and model drift is also there. You have to monitor your model and you have to do something. So you may need to acquire new data. So you may need to convince the department, that is the person who is in charge of data security, that why you need new data when your model is already deployed. Now why you need new data? So you have to convince that person. You have to do all this process once again, engineering, EDA and all that, and new model would be developed. That model will be replaced with the original model which started drifting, right? But for this, you have to request your higher managers to spare one person for doing this data EDA and feature engineering and visualization. So he will naturally ask that, because the same organization works on several projects, so he will naturally ask that why should I spare a person from other projects to your project? Is it that much need? So then you should be able to explain that yes, this model is excellent, still it was excellent, and it can again be excellent, but currently due to data drift or model drift, it has started, its performance has deteriorated, and that will reflect badly on our entire business. So whatever goals we had set at the beginning, that by applying data-driven approach, our profit will increase by 15%, our sales will increase by 9%. That may not be achieved if we don't take care of this. So what is the best way to convince your higher managers, senior people? Then obviously it should also be done visually, because they do not have time to read, say, 20-page document explaining each and everything. So model diagnosis and then convincing higher authorities, that also requires visualization. So okay, this was all verbal blah blah sort of, but now we will take some actual example. Here, as I said, I showed in the beginning, we have total 14, 15, 16 and 17, total 5 chapters on visualization. So here we will take only simple cases, and then in next chapters we will take more and more complex cases. Okay, so thank you and see you in the next chapter.